Before you lies the Frontier Drivein, a historic space being revitalized as an overnight stay in Center, Colorado. It's also the home to Ronald Rael's latest project, 3D printing adobe shelters. For more on Frontier Drivein, check out my podcast at the link in the description. All of the episodes have moved there, including the latest with Ronaldo and the Frontier Drivein creator. It would mean a lot if you'd subscribe because it's hard to start from scratch. On this channel, we're all about automated construction. We've featured a lot of 3D printed concrete, but there's two big issues with printed concrete and high cement concentration mortars. Mostly the cost and the sustainability. And the solution is behind me. 2 years ago, I filmed a different print of theirs. That was only one cylinder. This is 8 cylinders, which forms not only 8 separate spaces or rooms, but also one large common area in the center, which would be protected from the elements in a weather situation. We're going to hear from the company founder himself about how Emerging Objects was started, how this print was going, and what they see in their future.
My family has lived in this valley for 7 generations. And I still live in my great-grandfather's house where she grew up. So what we're printing with here is traditional adobe, which is made out of earth and straw and water. And so there's no chemical reaction that takes place other than drying. What's really happening is just that the clay particles are absorbing water and they solidify. So because there's no chemical process, this isn't hardening immediately. There's nothing that we are doing to make it hard other than drying by the sun. So we can only go in certain heights each time we print. So we print about a foot and a half. We print about a foot, I guess about a foot yesterday on this layer, and right before we left home, and now we're starting again. And so we kind of have, as a traditional practice, where we have to assess using our eyes and our ears and our fingers and understand the material, as has been done for centuries. And we're just assessing how high we can print. So we might put another foot here before we move to another location, allow that to dry in the sun, and then later on in the day or tomorrow we can return. So we're just basically moving the robot, which is very portable, from location to location to location, and just printing higher and higher each time.
I believe it's the most portable printing machine that I've seen.
Yes, I believe so. I mean, I conceived of this printer for that reason, that it could come out to remote environments and be placed anywhere, and that you can use the soil from that site to print buildings. And that's the whole premise behind this project, which we started about 4 years ago or so. It's actually started much longer, but we didn't have the equipment. It was just a kind of a vision, and a lot of the experiments were done in clay about 7 years ago, and now we're doing it at full scale. So we keep moving the printer every day, all day long, and so 2 people can just pick up the printer and move it out the door. And so we'll move it from here, and we actually have to build this one up to the top of this level before we put the lintels of the doors, and then we'll be able to spiral up on top of the doors. So we're going to now have a very new experience, which is to print on top of these, which we've never printed this high ever. So we're going to mount it on top of a platform, and then we will continue to print about 3 more feet on top of each one of these silos.
So you move the printer, and yet you're able to maintain a very uniform vertical line on the prints. How are you able to get it so precise?
Well, there's variations. I mean, actually, when we stop and it dries, there's expansion, contraction. Well, contraction as it dries, and so we do our best to keep it uniform. But as you can see, there's a kind of imperfection that are the imperfections of the day cycles, the day. There's a lot of variability in this, but we're just testing it and experimenting in its very raw state. So you see, we're about to stop the print right here, and we're about out of mud. We barely made it.
What's the process like when you pause?
We just stop. The beautiful thing about this, because there's no chemical reaction, we can add more water to hydrate the material. If we have any mistakes, we can remove it from the wall and put it back in the machine. If anything dries, we can hydrate it. So that wheelbarrow there, we're hydrating old dry mud, and we'll reintroduce it into this mix. So there's actually very little waste. It's very ecological in that sense. There's no chemical reaction. It's just natural earth, and all this is soil that can return to the soil in the future. And because we're in a high desert environment right now with only about 9 inches of rain per year, we are not going to surface this with anything. Like traditional buildings in this region were not plastered with any kind of cement, and so we are not going to plaster this with any cement. In the future, as a maintenance cycle, they could be earthen plastered, which is my recommendation, and that earthen plaster will last many years. And so if you compare that to paint, for example, you have to paint every so often, and so you may have to replaster every so often, but that earth is responsive to the weather and it's reusable, and so rain comes from particular directions, so you actually don't have to reapply the surface to the entire building, only in those directions that may get rain. And so this building doesn't have a roof, and so it's being constantly bombarded by the weather. And we have examples that we have made that are now 4 years old. I live in a house that's 100 years old that still is just earth. And so we see, there's this potential longevity to this and the reintroduction of this traditional building practice using this technology.
This cylinder behind you was the first you printed. Are there lessons learned even from there?
In a way, I can't say we printed this first. So we printed a certain height, and then we moved and we printed that height. So we're constantly moving across. So we're printing horizontally through this process, but there are a lot of lessons that are being learned. Lessons that pertain to how we respond to the weather, for example. When we began in the spring, it's very windy and very sunny, and that is a really optimal time to print because the earth is drying quickly. In the last 2 weeks, it's been rainy, so that slowed us down, and we have to calibrate how much we can print and how we move. And there's also, it's kind of a choreography right now because it's such a small crew and reliant on a portable machine. So there are 4 dancers in here, and one of them is the robot, and we're constantly moving. We're moving through this process. And so I think the biggest part of the learning is to know what comes next in every step of the way, and what we move and what we have to anticipate.
What stories do the lines tell that your expert eye can read, like lines of a tree or something?
Oh, well, I know the day that it rained because I can see if we print it and it rains right on the print, it doesn't damage it, but it will cause a little bit of, it'll exacerbate the erosion.
It'll show the straw over there.
Yeah, I can show you, like right here. Here was a day that it rained on us very hard while this was wet. And so you can see it's exposed the straw and it's a little bit soft. And there it has rained very hard on it after it's dry, and you can see that there's actually no sense that it ever got anybody, even though it rained probably much more up there than it did on this day because it was wet. And so we can look at this like lines of a tree. We can see the days that it was hot and it shrunk. We can see the days that sometimes our mud was wet, and we might see a few more cracks in the mud that are just, they're not structural cracks, but they're just surface cracks that we understand that because the mud held so much moisture and it cracked and it dried, it caused some cracking to occur. So yeah, it tells a story of weather just like a tree does, and also of our experiences as we're navigating this experiment.
Does the pattern help with expansion and weather changes?
Well, there's a couple things. One is we found that this pattern reduces the amount of cracking in a monolithic structure. So a lot of our previous structures are only about 3 inches thick, and this is around 9 inches thick. And our 3-inch thick pieces have reached this height, so it's very strong to print this way. There's actually a strength involved in that, and we have the luxury to do that because the material's free. Right? If you're printing with another material like concrete, and 3D printable concrete, which is expensive and has chemicals that cause it to solidify faster, you actually want to maximize the use of the material. So making a straight line is the best thing. But because we can corrugate this line, we can improve the strength, and we can also improve its massiveness and its thermal capacity as a material.
I'm Lodman, and I'm from Sudan. Definitely everything I'm watching right here in this project which is juxtaposition between cutting-edge technology and some of the oldest tradition and material, probably known to mankind. Mixing dirt that is going to be fed to the printer through this very interesting long nozzle that is going to be picked up by the arm of the printer with this kind of spinning around and do this kind of patterns.
If it dries, is that a big problem? Does that ruin your equipment, or is it easy even after it dries to clean it up?
Yeah, absolutely. The pump has a very kind of delicate and precise kind of a thin level of consistency. It is kind of sometimes a bit of a struggle to navigate that happy kind of spot, so we always make sure that we get the right position. We're always going to look there and see the feedback. If it's flowing, we're going to add a little bit of water. If it's going too fast, means that the clay is soft, and then we kind of harden a little bit by adding more dirt.
Awesome, man. Thank you.
So the printer emits a Wi-Fi signal, and so sometimes these earthen walls are so thick that I have to raise up the phone a little bit just to capture the signal.
Did you have to develop that addition to the printer, or did it come like that?
No, it came with the software and the particular board it's used. So the printer was built by my friends at 3D Potter, and so we collaborated on this idea of making a larger printer, and so they've commercialized it, and most people use it for printing pottery, but the beautiful thing about that is that it can print lots of pottery. And so the underlying software that we're making this with, I made into a program called Potterware, and so that's for printing pottery. And so there's a setting on that specifically for the scarab, but you could use it on the other PotterBots as well, that can print several ceramic objects at once of the same design. So if you're mass producing an object, you can print it over and over and over again. And so the scarab printer has the capacity to do that as well.
Do you have to like clear the nozzle or prepare it to accept the next layer?
No, we just stop it, and there's a little airspace because we ran out of clay, or at least so when we ran out of clay, so there's a little airspace. But no, we didn't have to do anything. We just stopped it and we started it up again. But right when we ended, I don't know if you saw, we had actually emptied this out of mud, so it sucked a little bit of air in the cage at that point.
So the little airspace is non-consequential in the grand scheme of things?
No, because it's very forgiving. I mean, we can take a little bit of mud by hand and actually just put it down, and that would be fine. So it's full of these imperfections. I sometimes can't imagine how, and I've seen on a cement on a concrete 3D printing site, there's just lots of broken chunks everywhere. And there's nothing to be done with that except for throwing them away. But our broken chunks we can recycle back into the process. And if we make a mistake, we can actually go back and repair by hand, either right away or down the road sometime. And that's kind of the beauty of working this way.
What is your goal for the next year?
So my goal for the next year is to scale this process, to think about how we can produce more quickly, larger, and this is the first step into working on a client-based project. Everything thus far has been experimental, and so this project is engineered, it's permitted, so in a sense it's not an experiment as much as these clients have allowed us to experiment, and they've recognized that this is a great experiment because it's the first of its kind. But taking these steps into being permitted, for example, and working with an engineer, testing the structural characteristics of the material, that takes us one step further into applying this to things like housing. And so those are the next steps that we want to take. So I'm both thinking about the work that's produced as contemporary sculpture, but also as steps towards producing housing. And for me, those go side by side because I want to make beautiful housing. And I want also to make really interesting objects in the landscape that allow us to experiment with space. So this project is highly spatial. You go inside and it's a sensory experience. It frames the sky. There's a sonic experience that has a lot to do in relationship with the landscape, but also with the film and the projector screen. I'm going to walk you through the material process that we use here. We start with it's basically dirt, but it's alluvial soil that has clay and sand and silt in it. And we screen it down to 1/4 inch because that's what the pump can carry. So this has already been screened, so there's no rocks in here that are larger than 1/4 inch. And we mix it with straw, and this is wheat straw, and this wheat straw comes from this farm right here. And we chop that wheat straw down into some really fine lengths, like 1/2 inch or so. And that's just because it maximizes, it doesn't get tangled up in the pump. And so we mix that all in this small cement mixer truck, and that material can stay in there for as long as we need. It's just as long as we rehydrate it, there's no chemical reaction, as I mentioned, and so it doesn't solidify in there. So it's kind of on tap. Whenever we need it, we can extract it. And over here we chop the straw with this mulcher. It's a leaf mulcher. And then we transport that mud to the pump with this ATV. And there's a trailer on the back of the ATV here. And we just take the mud and then we put it in the pump. And then of course the pump pumps it to the printer and we begin.
Very nice. Do you want to talk about all those rotor stators?
Yeah. I mean, one of our only expendable things here are these rotor stators from the pump. And they have a rubber stator that wears out over time because of the friction and the erosion from the material. And so they actually last pretty long. And so this pile here represents what we used not only this year but in previous years. So I think we've only gone through 4 rotor stators so far. And so they are somewhat expensive. They cost around $600 a piece. And they're basically the main part that wears out and that we have to replace. Beyond the gas to run the pump and the gas and the ATV, this is the main expendable part. There's not a lot that I know that can keep them going longer. What I did discover early on was that the metal auger that inserts inside of it, most companies sell them together, and that makes this a part that costs like $1,200. But I later discovered that if you really ask hard, they'll sell you only the exterior casing, and that way it cuts the price in half.
Yeah.
But there's not, I mean, one thing we do is we use dishwashing soap, and that helps lubricate them. So we mix our mud with a bit of dishwashing soap, and that helps keep these running a little bit longer. It seems to keep the friction down, at least based on the sound that we can hear. And of course we have to tighten them over time, but we've had more and more luck by creating material mixtures that are calibrated to the pump. And so a little bit of higher sand content. If it's too clay rich, it becomes too viscous and the stator has a hard time pushing the material through.
I would think sand would be more coarse and abrasive and ruin it faster, but it's interesting. The viscosity makes a big difference.
Yeah, it probably does, you're right. But if it doesn't have sand, then it's not going to push anything through it. It's just like spinning, and I think the clay is just, nothing's happening, it's just stuck.
But you're not adding sand, that just happens to be where you dug up the soil.
Happens to be where I dug up, and so even though there's not a perfect mixture, the clay lies on the top of the surface and then more sand lies below. And so I try to grab a ratio of material that is a good mixture between the two. Yeah. There's 2 things that I'm moving forward simultaneously. I'm moving forward making structures that take advantage of a 3D printer and the kinds of forms that a 3D printer can make. And there's an aesthetic component to that, an experiential component to that, and also making pragmatic structures like housing. And this has a pragmatism to it as well, because this will be another form of accommodation here at the Drivein. And so moving these 2 lines of thought forward is important, because if we make housing, I want to make beautiful housing. And if we make sculpture and art, if I make sculpture and art, then I want it also to be experiential and And of course there's this larger overarching thesis and ethos about the material, because I come from a tradition of building in earth. My family has lived in earthen buildings for possibly thousands of years. And so this is a continuation of that legacy and history, but using a different technology. There are several building codes, including the International Building Code, which has earthen technologies embedded in it. This is no different from Adobe or Cob, which have been standardized. And so I think it's very possible to situate this in the realm of those already standardized and approved building construction technologies. This printer is an upgraded printer from what we were using before, but it's fundamentally the same printer. The only difference is it has a slightly longer reach. And so we're actually using both printers on this site. The other one had a problem that we couldn't fix, so we sent it back to Danny at 3D Potter, and they're getting it repaired. And so ultimately, now that we're at our tallest stage, we don't want to move the printers around so much because it's really cumbersome to take it down, move it to the door, move it. So what we're going to do is we're going to mount 2 printers in each of the silos and just leave them there until they complete the job from here on out. And then we'll move them to the next site. So with the 2 printers, we should be able to move much faster. We won't run them in tandem because what we want to do is stagger them. So we're printing and then allowing that to dry, printing, and then by the time we're done printing the next one, we can just start the next job and move between the 2 in a staggered drying phase.
Optimizing your mixer bond system.
Yeah. My family has lived in this valley for 7 generations. This is the Frontier Drivein. And it's a historic drive-in. I believe it began in the 60s, and if I'm correct, it closed down in the 80s. I had been to a movie here when I was a child, and it's surrounded by 13 and 14,000 foot mountains, and also by center pivot sprinklers. And so there's an interesting relationship between these center pivot sprinklers that rotate around in circles and grow crops, potatoes, wheat, alfalfa, and the project we're doing, in which we have a polar 3D printer that's also spinning around in a circle and depositing earth to build these structures. There are many Adobe potato warehouses in these surrounding communities. There must be hundreds and hundreds of them, and they've been here for a long time. This pattern that we're making emulates potatoes, and so it looks like stacks of potatoes. So we're making this connection to this landscape, to the way that crops are grown, and to this giant circle which is this valley, and these center pivot sprinklers which are spinning around, and there's this connection in terms of form and space to the larger context. And I still live in my great-grandfather's house where she grew up. So, living in a community village where you move between houses and you eat in meals in different houses, and so that village was a family village where everyone was related growing up.
And what type of construction was that house built with?
So that house is built out of Adobe, and then there was an addition in the 60s made out of wood frame. And so the Adobe house is around 90 years old now, and that little village is comprised of. There were a lot of Adobe houses there when I was a kid, but people have left and abandoned them, and so I own the last 2 remaining Adobe houses in the village. My great-grandparents built that house, and then my great-grandfather's sister's family built the other house. My mother lives in that village, and there's a stone schoolhouse and a cemetery, and that's what's left of that village. Traditional Adobe buildings, like my grandparents' house, is made out of Adobe bricks, or adobes they're called, but they're bricks that are sun-dried mud, and so there's a process to that. You'd have to dig the dirt, mix the dirt, and mold it in bricks, and you'd have to make thousands of bricks. So what's different in this process is that I have an automated sifter and a very large mixing machine, and rather than making bricks, we're going directly to the making of form. We're stacking the wet mud with the machine, and so there's a step removed from that process. My assumption is that it's faster in that way, that we're going straight to the form. And so in 8 weeks we've done this. It may take 8 weeks just to make the bricks first and stack them, and then start the process of building. And you actually can only stack Adobe so high every day as well, because the mortar will compress out, and so you have to be conscious of how high you're stacking those adobe bricks in the same way that we're stacking. So I think there's a speed advantage to making things this way, and there's also an advantage of form, of space. Like I can make a round and straight and curved. I can make any shape I'd want, which might require particular skill to make something other than a straight line. So once these two are aligned, we reach the level of the height of the door. So we can lay the wooden lintel in place, and then from there, we're just spiraling in circles all the way up, and so we can move between these two right quickly. But if we move this printer now on top of there, because we've never done that before, it's going to be an effort to put it up there, level it all, get everything set, and then print a foot, and then say, okay, well, we're going to come back down, and that's something that I'd rather not do right now. I think it'll be more efficient if we just stay between these two and catch them up to this level. Hopefully the other printer arrives in time, and then we can just set it there and then keep going.
Awesome.
Yeah.
Is there any reason to do this besides the look?
It helps preserve the wood a little bit. Helps protect the wood, and the look is good too.
Smells good too.
Yeah. This is all beetle kill pine. So there are a lot of sawmills in the area that cut down the dead pine trees, so they're standing dry. And so it makes for some really straight, beautiful wood, even though it's part of a natural disaster, basically.
What kind of beetles?
Or a man-made disaster, I should say. They are a pine beetle that typically does not live in this kind of climate, but because of climate change, they've migrated to climates that are typically colder. And so now this is a climate that's warm enough for them, and it's devastated millions of acres of forest. Right now we're ending for the day, and so this material will dry, and so I'm just putting a cap of water on it, and so that'll seal it up so it won't start to harden. And tomorrow it'll be ready to use.
The concrete guys are quite envious of that, I believe.
Yeah, don't tell them.
How did today go?
Today went very well for printing. We didn't do a lot of printing, but we did a lot of setup for future printing, because we're going to extend the top of those silos about 3 more feet. Tomorrow we'll be able to finish this so it's level with the other one, and we'll set the lintels for the doors, and then it'll go quite quickly because we can bounce the printer between the two spaces and catch these up with those until we need the larger scaffolding and the larger setup. And once we have that and we have the 2 printers in place, I think we'll go really fast.
My name is Randy Barrientos, and I work for Continuum Partners out of Denver, Colorado, and we're doing the Drive-In Theater at the Center, Colorado, actually, called the Frontier Drive-In. Very unique piece of property.
How many units?
We're going to have approximately at full debt, we're going to have 50 rooms. Right now we have 14. So we are working on getting more open. So we're getting excited about at least getting it open right now and doing some test runs. So we've been testing the screen on not a nightly basis, but a weekly basis, and it's coming out pretty good. That sounds great. The screen is excellent, so I think it's going to be exciting to have movies here.
With your experience, what do you think the construction cost difference is between one of these different types of units and the Adobe print they've got going on?
Well, the Adobe print is pretty unique, so it's hard for me to even compare because I'm not sure really what that 3D printer was. Probably an investment you had to make that was quite sizable, I'm sure. But the units that we've got and everything are a little bit different. They're not your standard everyday run-of-the-mill units. They're definitely outside the box. So they were a little bit costly to do as well, but they're really unique units. Very well done, very well.
Cool, man. Thank you, Randy.
Hey, man, for sure.
You can see today they printed from down here where it's still dry up to here where it's wet. We'll come back in the future and see the progress that they've made, so make sure to like and subscribe so that you don't miss when I come back next time.